Good morning. My name is Marko Delić, and I will present our research. Main goal of our research is to determine influence of printing parameters on compressive properties of ABS material. In this research, we use ABS material and FDM technology. We know that ABS is one of the most commonly used materials and PLA, but ABS have better mechanical properties. Melting temperature is from 210 to 235 degrees. He has a longer service life than nylon, and he is very cheap material and can be used for many applications. Our experiment is divided at two small parts. In first, we tested solid specimens. Specimens were printed with 100% infill density, and in second part of experiment, specimens were printed with the infill pattern, with different infill patterns. All specimens were done according to D695 standard. In this moment, doesn't exist standards for testing of 3D printed polymers. And then we use a standard for rigid polymers. All samples are made on the 3D printer maker with replicator XX. He used FDM technology, and all tests were done at universal testing machines Vicrol Z100. According to standard, specimens could have the two shapes, could be cylindrical or cube shaped. For every experiment, we printed the three specimens just to check repeatability. All specimens are measured, their weight, dimensions, and in this table, you can see printing parameters that we considered in our research. Printing orientation. It is orientation of specimen on printing table. We have two printing orientation, horizontal and vertical. Printing speed, it is a speed of movement of print head. And we have two values. 90 millimeters per second is a value that MakerBot recommend. And we have a lower speed that is 20 millimeters per second. At this speed, 90 millimeters per second, nozzle has 230 degrees of temperature, and at a lower printing speed, that nozzle temperature must be lower, 220. Layer height, that is height of one printed layer, 0.1 and 0.2 millimeters. Infill pattern. Two most commonly used infill patterns are rectangular and hexagonal. Unfortunately, MakerBot doesn't support triangular infill patterns, so we use only these two infill patterns in our experiment. And we vary infill density, 10, 40, and 70%. Infill density is how much material is how much material is specimen printed. In first part of experiment, we tested solid specimens and checked impact or influence of printing orientation, horizontal, vertical, printing speed, and layer height. And this is a plan, experiment plan. You see experiment designation. We have eight experiments, and after testing, we gave results, and we are going to analyze compressive stress. We say that ABS is very brittle material, and we know that based on tensile testing. At very low strains, force is grow very fast and coming to fracture. But when ABS is under compressive force, material have some formability. We decided to stop experiment, to end experiment at 12.7 millimeters at half of specimen height. You can see results, and first 4 experiments are with horizontal. Horizontal printing orientation. Specimens are printed on this way. And we see that compressive stress is a little bit higher for vertical specimens printed with vertical printing orientation. Specimens printed with lower layer height have better mechanical properties, and then that are printed with 90 millimeters per second with the recommended printing speed have something a little higher mechanical properties. We can see here compressive stress strain diagram and see that that the difference isn't so high. These are results for horizontal and for vertical printing orientation. In this histogram, we can see all the results, and if we horizontal and vertical printing orientation, we see that compressive stress is bigger for specimens printed with vertical printing orientation, and we can say that it is expected because it's, for these specimens, compressive force is perpendicular on printed layer. And we can say that vertical printing orientation is better than horizontal. If we look at results for layer height, we see that smaller values of layer height brings better mechanical compressive properties, but that isn't so big difference, and printing time is going to be double. And at the end, we can say that it is better to print with the recommended printing speed. We know for printing orientation for every parameter which factor is better to use, but it is recommended to check this statistically. We have 8 experiments, and we can analyze the results as Taguchi L8 matrix. We have 3 parameters: printing orientation, printing speed or printing velocity, and layer height, and two levels of these parameters. We know for each level, for printing orientation, it is horizontal is better. For printing velocity, it is 90 millimeters per second, and for layer height, smaller layer height, 0.1 millimeter, gives better compressive results. But when we analyze this statistically, calculate signal to noise ratios, we can calculate delta and make rank to know that biggest impact on mechanical compressive properties have printing orientation, then printing speed, and smaller influence have layer height. In the second part of experiment, we used rectangular and hexagonal infill pattern and 3 values of infill density, 10, 40, and 70%. We made testing and see that you can see by strain that for rectangular specimens, for then with higher infill density for 40 and 70%, we ended experiment at 12.7. For a rectangular infill pattern and 10% infill density, we have low strain, very fast come to fracture of specimen. Similar is for hexagonal, and we can see that compressive stress is similar for a rectangular and hexagonal infill pattern at low values of infill density for 10%. That's very similar, but for higher values, a rectangular infill pattern gives much better compressive properties. You can see diagrams compressive stress strain, and as we already said, for specimens with a rectangular infill pattern, we ended experiment by the planet, half of specimen height, and only for a low values of infill pattern come to fracture. For hexagonal, we ended all 3 experiments before 12.7 because come to fracture of specimen. Here we can see summarized results, and we can tell that rectangular infill pattern gives better mechanical properties, except at low values of infill density. In that case, all specimens with both infill patterns fracture very fast. And of course, with higher values of infill density, we have better properties that is expected. Some conclusions, of course, solid specimens that are printed with 100% infill density have much better mechanical compressive properties than specimens printed with infill pattern. But if we must to print parts with smaller weight, better is to use rectangular infill pattern than hexagonal. And we can say that when we print solid samples, the main parameter is printing orientation, then printing speed and layer thickness. Vertical printing orientation gives better results than recommended printing speed, 90 millimeters per second, and smaller values of layer thickness lead to better mechanical properties. This research was just a small part of our research. Our topic is to determine, is there possibility to print these for sheet metal forming, and to make topology optimization of that. And we need to, our topic is to, our future research is to make this compressive testing with the numerical simulations. And main problem is that most of these softwares use some flow curve equation that couldn't on good way simulate forming of polymer materials. We made one experiment with Simofox forming, and this is comparison. This is our result from testing for Zwick roll, and this is what we get by simulation when we use standard flow curves equations that we use for metal, and that will be our future research.